Ladies and gentlemen, please put your hands in welcoming on stage our keynote speaker, Mr. Tirthankar Lahiri, Senior Vice President, Data and In-Memory Technologies Group, Oracle USA. Mr. Lahiri is a Senior Vice President and Data and In-Memory Technologies Group for Oracle Database and is responsible for the Oracle Database Engine, the Oracle x10 in-memory database, and Oracle NoSQLDB. He has over 20 years of experience in the database industry and has worked extensively in a variety of areas, including manageability, performance, scalability, high availability, distributed concurrency control, in-memory data management, NoSQL, architecture, etc. He has 38, I repeat once again, he has 38 issued patents and several pending patents. Ladies and gentlemen, please join me in welcoming Mr. Tirthankar Lahiri.
Thank you very much for that intro. Can you guys hear me at the back? No? Can you hear me now? Is that better? Okay, thank you. So I'm going to talk about autonomous database and how it helps us solve an important dilemma facing data architects today. I'd like to start by describing Oracle's overall mission statement. Oracle's mission is very simple. It's all about the data. It's to manage, analyze, and protect the world's data for the benefit of all. Now, how many of you here are active Oracle database users? Okay, I'd like to tell you, you are all Oracle database users, whether you like it or not, because we use databases every day in every aspect of our lives. If you make a cell phone call, if you book air tickets, if you draw money from an ATM machine, every basic everyday activity runs essentially on some database. That's very likely to be Oracle database. Oracle database quite literally runs the modern world. It runs almost every major industry. I keep saying, there's many companies nowadays, many high-profile companies, social media. If Oracle disappeared, or if Facebook disappeared, which would have more impact? If Facebook disappeared, I would get more work done every day. If Oracle disappeared, basically, modern life would come to a standstill. 98% of the largest companies in the US run and depend on Oracle database. 92% of the world's largest companies, they depend on Oracle database. If you look at the total economy size of all these companies, it exceeds the GDP of almost every country. It's about $14 trillion of revenue that these companies account for. So it's the third largest economy if you think of Oracle customers forming a separate country. A very, very impressive financial ecosystem. So I'd like to quickly describe, at a very high level, a brief history of enterprise data management so that you understand where we came from and where we're going next. As you know, most of you know, the enterprise era began with mainframes. It moved to client server. Then it moved to internet computing. And now we are very much in the cloud era. The mainframe era was very, very interesting. There were two different paradigms that were fighting with one another. There was one paradigm of databases where this paradigm said, you tell the database exactly what to do. So if I want to go to the Kolkata airport, I would tell the database turn by turn how to get there. The other paradigm was the relational database, where I would just tell the database, take me to the airport, and you figure out the best way. So the paradigms were imperative, based on specific directions versus declarative. In the client-server era, the relational database became the dominant platform. And the reason was the relational database empowered generations of developers. It made it easy to write applications because the database took care of basic things like the language, transactions, data integrity, security. And developers could really focus on application logic, which is basically what development is all about. The internet era brought about another change in databases. It basically made requirements extreme. So Larry Ellison said, the internet changes everything. Anyone remember these quotes from the 90s? Some people do. The network is the computer, Scott McNeil of Sun Microsystems. So volume, scalability, availability requirements became extreme. Some new database technologies appeared, like object databases, but they quickly disappeared as the mainstream relational databases adopted these technologies. And of course, security became very important with the internet, because the internet has a much larger attack surface area. Now, we are very much in the cloud era, where the cloud essentially makes developers a massive online population. It really empowers developers. In fact, the cloud is the first technology generation where anybody really can become a database developer by using database services. And the cloud era further increased requirements to scale, because the cloud had massive populations of developers and users. So it was during this period of cloud explosion that single-purpose database systems built for specific tasks became popular again. And this was started by the web giants like Google and like Facebook that had very specific data management needs, extreme scale. And so there was a category of databases called NoSQL. Anyone heard of NoSQL? A few people, yes? So NoSQL, or not only SQL, became popular because people thought, I can't solve my problem with standard relational databases. So databases like MongoDB, Couchbase, etc., started to become popular. Now, they did provide scalability and performance, but they had trade-offs. And Oracle, by the way, was not sitting still. Oracle observed the cloud era trends and kept evolving into what we now call a converged database. Oracle is no longer just a standard business relational database. It has many different types of algorithms, many different data models, AI, machine learning, spatial graph IoT. So, basically the two trends were single-purpose databases and Oracle converged database. That's the state of the art today. And this gives rise to the present-day dilemma for data architects. If you are building the data fabric for your enterprise, what direction should you take? Many single-purpose or a single converged database? So let's look at some of the trade-offs with these choices. The first thing is, I'm actually losing the last line of my slides, but never mind, I'll read it to you. So the first thing is I wanted to make sure people understand that you need single-purpose databases for microservices is actually a myth. Because you have a graph service and a document service and a machine learning service, some people believe I need to have 3 different types of databases. The reality is you need to have separate algorithms and separate data models, but not separate databases, which you can do both with many databases or one converged database. The other thing is each of these single-purpose databases have specific shortcomings. Many of them lack things like integrity, security, declarative languages, and each one is different. So they need special skills. They also create a big infrastructure problem, because if you have your enterprise depending on 8 different databases, keeping data consistent, running reports, managing security becomes very, very complicated. Each one has to be upgraded independently. Taking a backup consistently is very hard, because each of these databases is different. And this is actually a slide from a very well-known web company, I won't mention by name, but this is their slide for their architecture. And they presented this as the way they run their business. Now, if you look at this picture, there are 9 different databases here. So imagine the difficulty of managing this. I call it die by DIY, die by do it yourself. I'm not a DIY person. If anything breaks at home, I call an expert. But you can die from DIY unless you know what you're signing up for. this architecture might work for this web company because they have highly skilled MIT computer science PhDs running their business, but it's not meant for everyone. There are multiple technologies, multiple stores. Running reports is very tricky, security is hard, consistency is hard, and it's complex. So, it's easy to build something like this and then end up with this explosion of complexity. So the question you might ask is, okay, great, I want to use a converged database, but does it scale? And the answer is yes. Oracle has made major scaling advances over the years. I've been at Oracle for a very long time, and each Oracle database release has added major functionality for scaling to very large population sizes. As you can see from this slide, I'm not going to go into it in detail because I could spend the whole day talking about this, but every Oracle database release and every release of Oracle Exadata, which is Oracle's database machine, has added significant functions for scaling. And Exadata is Oracle's database platform machine, released in 2008. Every year, Exadata and Oracle database have advanced in scalability. I could spend all day talking about scalability, so I won't. But if you look at this slide, you'll see some real-world examples of how large the workloads Oracle database can run. SK Telecom runs 65 billion transactions per day. The US Department of Homeland Security runs over 35 billion operations per day on an Oracle database over 1 petabyte in size. And the New York Stock Exchange runs everything on a single Oracle database, over 1 billion database transactions per day, generating 15 terabytes of data per day. These are real-world hyperscale workloads that run on Oracle database. Now, can Oracle deliver the functionality of many special databases? Is it possible if Oracle is a good relational database and everything else? Well, the good news is, the answer is yes. And it's not just us who say that. Gartner, which is a very, very influential and very well-respected technology research firm, rated Oracle as #1 in every single use case for operational databases, beginning from traditional transactions, to document or distributed variable data, to streaming data use cases, and to what they call augmented transactions, which are transactions that also run reports. And Forrester, another very important database research analyst, recently gave us the top score for both vision as well as current product for being the best translytical database. Because nowadays, people don't run pure transactions, they run translytical workloads, transactions plus analytics. So the analysts believe that we have the best converged database in the industry. I'm not going to go through all of Oracle database's converged features in this session, that would take too long, but I'm going to mention just one here. Machine learning is something Oracle database supports natively. You don't need to extract your data into another machine learning framework and run machine learning on that data. You can keep your data in Oracle database, use all the parallelism, all the power of Oracle database, train your models inside of Oracle database, and run inferences. So if you desire, for instance, if you have a credit card application, you can train that model to detect credit card fraud. And then as a transaction runs, you can score that transaction right away and disallow it in the transaction's path, not after the fact. Because fraud detection, you can't wait. You have to check right away, is that transaction valid? So these are possible because Oracle has this wealth of machine learning technologies built into the database. And it's not just machine learning. Oracle database has support for documents, for spatial data types, for graph, for every type of data the modern enterprise might require. Now, so I've proved to you, hopefully, Oracle database can scale, can hyperscale. Oracle database is a converged database. What about a hyperscale converged database that is augmented by machine learning? And the answer to that is Oracle's Autonomous Database. Oracle's Autonomous Database is Oracle Database's latest offering on the public cloud. Speaking of which, Oracle now has a new data center in India, so you can get autonomous database in India, hosted within India's geography for compliance reasons. Autonomous database is a self-driving database. We call it self-driving because it basically runs itself. It's a fully scaled out database with scale out, fault tolerance, and disaster recovery. It runs on Exadata, Oracle's premier platform, and it's fully compatible with all Oracle databases. It is self-securing, which is very, very important for IT enterprise architects. It automatically, you don't miss security patches. I always say security is as weak as your weakest link. You can have the world's best home security system. If you leave your kitchen window open, your house is not secure. With autonomous database, that's not possible. It completely secures itself, fully encrypts all data, and protects your data from even administrators. It is self-repairing. It recovers automatically from any failures, provides extremely high uptime, including maintenance. So you basically get 4 nines and 5 uptime without having to do anything. This type of architecture needs a lot of work to build in practice. So instead of the DIY, dying by DIY, you basically get that as part of autonomous database. And also as your needs change, because businesses do grow and shrink in demands, there are seasonal fluctuations in demand, the autonomous database automatically scales itself, scales up and scales down based on your workload's needs. So it's a fully self-provisioning database. It doesn't require human intervention to change the configured amount of resources. Now this all works because behind the scenes, there is a huge amount of machine learning at every step of the stack. The database infrastructure is monitored via machine learning. If any server looks like it's sick, any network switch is problematic, any storage device is showing issues, we detect that, we quarantine that automatically without user intervention. The database operations are also monitored via machine learning. We detect database hangs automatically. We detect anomalies, any difference of behavior from normal behavior automatically. We identify when we're in a maintenance slot so that we can make preventive actions happen. And if problems are discovered, we can either match them to an existing issue and apply that fix automatically, or say this is a new bug, please address it. Again, it takes away hours and hours of DBA time by making this simple. And the workload constantly optimizes itself. The query optimizer runs constantly, changes, checks to see what's happening with the data, gathers statistics in real time. Even index creation, which is a problem of many database systems today, how do you decide what to index? The database automatically, through machine learning, selects the right indexes for that database to run optimally. So huge amounts of time savings to run your enterprise application. Again, to go back to the original reason why relational databases succeeded, the autonomous database takes away a lot of the headaches in building applications, because now you can again go back to building applications and let the database basically run itself. This has been a really successful product from Oracle. We've already got a very large number of customers who are very happy users of autonomous database. What is interesting, across all the customers is if you look at the customers and what they have said, they've said 2 things. My workload ran faster and I spent less money. It's rare to get both things together in life. It's rare for me to get something which costs less and is better. Usually it's the other way around. I get things that cost more and are worse. With autonomous database, if you look at the quotes from, say, Jassy, for instance, or from TaylorMade, they all said the same thing, that performance became better because it takes away the guesswork of figuring out how to configure, how to tune, how to manage your database system. And the expert system we have inside the database actually runs continuous. So even a really good DBA, And there are many really good DBAs out there. I'm sure some of you are in the room who are very experienced DBAs. Even the really good DBA isn't looking at the database constantly. The expert system never stops watching the database. So constantly, no matter what is happening, it's like the night watchman. It keeps watch, it monitors itself, and it tunes itself to get you the best performance. So this is why this has been a very successful product from Oracle. I'd like to conclude with a quick analogy, hopefully that all of you will understand. Anybody here today carrying a phone that does nothing but make phone calls? Anybody carrying just a regular phone? Okay. Anybody here carrying a regular camera? Not from the people in the back, but anybody in the audience? A conventional camera? Anybody carrying a GPS device? Nobody. I wonder why that is. Because most of us have this. This is the ultimate converged device. You know, in the 2000s, people carried PDAs. I still have a regular conventional camera. I haven't used it in 3 years. I have a camera. I think I still have a GPS device. I have a PDA somewhere. That's a collector's item. But once the smartphone came about, it basically took all those devices and essentially made them obsolete. Now, sometimes a real specialist might want an SLR camera to get the best pictures, but for most people, I haven't used my SLR camera in years. My iPhone works perfectly. So the same model, a converged autonomous database, basically gives you a huge simplification of your enterprise architecture. I would like to end with a testament to my most favorite science fiction character of all time. Anybody recognize this gentleman here? Thank you. Okay, good. So Spock, the modern enterprise is evolving. It's not going to stop evolving. And as the enterprise evolves, it discovers new needs, new workload types. So our mission from Oracle, basically, is to follow the modern enterprise, to basically fulfill the requirements of the next generation enterprise, and to boldly go where no database has gone before. Thank you very much. Thank you.